Section 7.5, an algebraic approach to vectors in this section. That's what this section is about. We did the geometric approach in section 2.5, and now we're doing the algebraic approach. So what we're going to do here is we are going to look at the vector. Let's say we are given a point A comma B in the xy plane somewhere. Okay, so the point, the direction that we draw here, or we call it the ray, if you take it from the origin to that point, that's vector v. Let's say I'm gonna put an arrow to represent a vector. So if you drop a height down there, this is A, this is B. So that's called the standard position of the vector. This vector has two components, one called horizontal components, which is in the A direction, and vertical component in the B direction. Those are called the components of the vector. So if I want to write down the components of the vector, we write, as we write points using the parentheses, as you can see here. But vector, there are two things. First, we put an equal sign, and we put this kind of parentheses, A comma B. It looks like less than or bigger than. That means when I see this, that means vector AB, vector V with components AB. So if I look in this triangle here, I can find the magnitude of the vector by using the Pythagorean theorem, which is a squared plus b squared. That's the magnitude of the vector. So if I want to find, of course, and as we did before, if you want to find tangent theta, theta is this angle here, is the opposite over adjacent. So from here we can find theta by using tan inverse of b over a. So if we are given a vector, vector v with components, let's say -3, 4, and we are asked to draw the vector in standard position. And find its magnitude. Find its magnitude. So how do we find that out? Well, first we are going to plot this. Think about it as a point, but it's not a point, it's just a vector. So it's -3 to the left side and 4 units up. So 4 units up here. That's the vector. The ray that goes from the origin to that point, -3, 4, that's the vector v. Okay, that's the standard position of the vector. Okay, from O to that point, -3, 4. And if you want to find the magnitude, regardless if you drop the height as I just did or not, the magnitude of v is always the square root of the x component, don't forget to square the negative, and the 4, because that's a distance. So if you put -3 like this, or just 3, it's fine. So that's the square root of 9 plus 16, which adds up to 25, and that gives us the magnitude of the vector is 5. So that's only just so you can see a vector. What kind of operations we can perform, algebraic operations on vectors. So let's say we have given vector u with components x1, y1, and vector v with components x2, y2. So then if I want to find u plus v, vector u plus vector v, the way you do it, you add the x components of the vector and the y components of the vector. So when you add u and v, if you remember from section 2.5, the geometric interpretation of this, you get a third vector, which we called it the resultant vector. So that's why we put these symbols here, or these parentheses, kinds of parentheses that we have here for these vectors. Can we subtract vectors? Yes, we can. All you do is x1 minus x2, y1 minus y2. What about scalar multiplication? So if I have, let's say a is a scalar, and I want to multiply it by vector u, all you have to do a times x1, a times y1. That's scalar multiplication. A is a scalar, means a constant. Okay, and that can be applied to to any vector. So another thing to learn here is that we can write that vector, because on the xy plane we're gonna see in a minute that it has, when we go 1 2 3 -1 -2 1 2 -1, this is a vector and this is a vector. I'm gonna call it I and I'm gonna call this J. So this has 1 comma 0, this has 0 comma 1. We can put it on this side. So I and J, all or any given vector can be written in terms of these unit vectors, we call them, because their magnitude is 1. So how is that possible? So you remember it was x1 comma y1. This can be written as x1i, and I like to put the arrow there, y1j, y1j. The same thing with vector v. Note the magnitude of vector I is 1 and the magnitude of vector j is also 1. Those are called unit vectors. Unit vectors. So let's look at an example on all of this. Let u be a vector given as -4 comma 1. V is given as 6 comma -2. We need to find and simplify, let's say, u plus v first, u plus v. So when you add them up, -4, 1, added to another vector, 6, -2, that would be, add the x components, which is 2, 1 plus -2 is -1. So that's the u plus v. U minus v, u minus v. You can write it if you like, you can write it u u plus -v. U was -4, 1 plus -v, multiply the vector by negative, so it's -6 comma 2. And now we can add that up. -4 plus -6 is -10. 1 plus 2 is 3. That's u minus v. Okay, and now the next one, let's say we are asked to find 4 vector v, so 4 times vector v. So that would be 4 times vector v was 6, -2. And all we have to do, multiply the 4 with each component. So that's a 24 and -8. Now we can write u and v, these two vectors, we need to write them in terms of unit vectors. I and j. So how do we do this? It's very easy, straightforward. For vector u, it was given -4, 1. Then we can write as -4i plus 1j. For the vector v, was given as 6, -2. It can be written as 6i minus 2j. Minus 2j. And those are called vector component forms. Vector component form. So we can look at other examples. Example, let vector u be 6i plus 3j, vector b be -i plus 7j. We can ask to find vector u plus vector v, -2 vector v u plus 3 vector v. So for u plus v, this is 6i plus 3j minus I plus 7j. So that gives us 5I plus 10j. For the next one, this is negative 2 times u is 6I plus 3j plus 3 times negative I plus 7j. What does that give us? Negative 12I minus 6j minus 3I plus 21j. Negative 15I plus 15j. It's like algebraic operations. We distribute the negative 2 and then we distribute the 3. And then we combine like terms. So that's the simplified answer for the second part. So now let's look at another example. Let's say we have vector v has its tail at the origin and makes an angle of 50 degrees with the positive x-axis. With the positive x-axis. If its magnitude is 20, write vector v in terms of I and j. So how do we write that in terms of I and j? So let's sketch a quick figure here. So it makes angle 50. It's a tip here, the tail at the origin, so it goes up this way. It makes 50 with the positive x-axis, right? So if you drop a height down this way, we need to find the components of this vector, call them a and b. This is vector v. So to do so, what we need to do is use sine 50 is the opposite over the hypotenuse. So that's the magnitude of v. So from here, cross multiply. B is magnitude of v sine 50. And they give us the magnitude of v was 20. So 20 times sine 50 degrees, which we can find here. So we can find and round. So 20 sine 50, it's about 15.3. Now we can do the same thing for cosine. Cosine 50, use it, adjacent over the hypotenuse. So then from here, a by cross multiply the magnitude of v cosine 50. Cosine 50. Then a equals 20 cosine 50 degrees. So 20 cosine 50 degrees. So that gives us a is about 12.9. Now, how do we finalize it or write v in terms of I and j? Then vector v equals, the x component was 12.8 and 9. So 12.9 I, and the vertical component was 15.3 j. So that's what I was required to find. Now we can generalize this to for the general case. So if vector v is in standard position, and theta is the angle that v makes with the positive x-axis, then the vector components of v can be written as the magnitude of v times cosine theta I, because that's how I got the 12.9 in the previous one. Look at this one. I found it's v cosine 50. 50 was theta. So that give me a, or the x component. And then how did I find the y component? I did magnitude of v sine theta j. But if you do not remember, it's fine. You just go step by step as I did in the previous example. Theta is given and the magnitude of v is given. So you just find each one and then combine it to get something that looks like this box formula. But if you know it, you know the box formula, you can go straight forward and substitute the values in. So based on the previous example, what we can do to find the components of v, or write v in terms of I and theta, the magnitude of the vector was 20 cosine 50 degrees I plus 20 again sine 50 degrees j. And if we put this in the calculator, this was calculated as 12.9 I, and the other one was calculated as 15.3 j. So that's if you know the formula. If you don't know it, it's okay. You can go step by step and calculate it. So other example, what about if we are asked to find the magnitude of vector, call it w, it doesn't have to be u and v all the time. Let's make it square root of 2I minus 3j. So how do you find the magnitude for this? The magnitude of w is the square root of the first component squared, no I, no j, and always plus, because of the Pythagorean theorem, negative 3 squared, no I, no j. So then the magnitude of w is given as 2 plus 9. So the magnitude of w is the square root of 11. Same for vector u with components negative 5j. There's no I. So what does that mean before we find it? This means it's a 0I, there's no I, plus, or you can say minus, just minus 5j. Then the magnitude of u, always the square root of the first one square, no i's, plus negative 5 square. And what does that give us? The square root of 0 plus 25, which is 25, and that gives us 5. Look, another example, same for, we would like to find this if u is 2I minus j and v, vector v is negative I plus 7j. So how do you find the magnitude of that? To do so, we first need to know what u plus v is. What's the vector components of this? And first thing we do is we just take the first vector and then the next vector, combine like terms. The 2I minus I is an I, and then plus 6j. Then the magnitude of u plus v would be the square root of, there's a hidden one there, so it's a 1 square plus 6 square. And that gives us the square root of 1 plus 36, which is the square root of 37. You can put in the calculator or leave it in radical form. So in this section we learned more about algebraic components of the vector. How we draw the vector in a standard position. Always the origin is going to be the tail of the vector, and then the tip of the vector is going to be another point. How do we find the magnitude? How we find the angle that the vector makes with the positive x-axis, and that gives us usually the direction of the vector. How do we write vectors in terms of I and j, those are called unit vectors, because if you find their magnitude, it will be 0. So if you like to see that, note vector I has components 1, 0, and vector j has components 0, 1. So if you want to find the magnitude of vector I, is the square root of 1 square plus 0 square. So that gives us the square root of 1 plus 0, square root of 1, which is 1. That's what we call the unit vector. And the magnitude of vector j is the square root of 0 square plus 1 square. Is the 0 plus 1, again square root of 1, and that gives us also 1. So that's the magnitude of vector j. Those are called unit vectors. That's what this section is covering. Talking about unit vectors, I and j, how to write a vector in terms of the unit vectors I and j, how to draw a vector, how to find its magnitude, how to write write the vector in standard position with this format. Magnitude of v cosine theta that the vector makes with the positive x-axis, I plus v magnitude of v sine theta that the vector makes with the positive x-axis, j.